Bismillah ar-Rahman ar-Rahim. Today I'm going to show you how to model and simulate Verilog code using ModelSim integrated development environment. Okay. First of all, I'm going to show you how to download ModelSim, where to find it. So you just need to go to Google and then search for Intel Download Center. Okay. Click on that, and then most likely it will be the first result. Okay, click on this, and below here, okay, you'll find Intel FPGA. Okay, Intel FPGA. All right, just click on that, and then you'll find a list of products, 259 products. Okay, but we would like to limit our search to Quartus Lite, LITE 20.1.1. Okay, hit enter. The result becomes 67, and then most likely it will be the first one, but just make sure that this is Intel Quartus Prime Lite Edition. It must be the Lite Edition. Design software version 20.1.1 for Windows. Okay, for Windows. Click on this, and then scroll down to download section and click on individual files. Okay, and then you'll see ModelSim Intel FPGA edition includes starter edition, and then click on the download button for ModelSim. Once you click on the download, you may get an license agreement where you need to accept. If you don't, it means you have downloaded it before and you don't need to accept it anymore because you have accepted it before. That's what happened in my case. I don't need to download it because I already did. So I'll just stop the download here. It's a big file, by the way, 1.2 gigabytes. Okay. So once you download it, you can go to downloads, okay, or wherever you download it. And double click on the file, and then just make sure, please make sure that when you click on it, let me double click. Maybe I'll just need to show you a very important option, which is basically the default option. Just don't change it, okay? Which is the option in which to choose the free version or the licensed version. I want you to choose the license-free version, okay? License-free version, and then for that, let me show you where you can see that. So the installer is starting. You just click next for the welcome screen, okay? And then here, this is what I'm talking about here. So you need to make sure that this option is selected. Okay, this says here license is not required. Okay, and then the rest of the installation process is straightforward. That's it. Okay, you need to install it until the end, and then start it from the start menu. Okay, I have already installed it, so I'll close this installer and then start it for you from scratch. Yeah, let me just close this from the previous session. Okay. Okay, so just type here ModelSim, and you'll get this product that you downloaded. So click on it, and you'll start ModelSim. Okay. It will open up the project that you created the last time, okay? But if you haven't created any project, it will start empty, okay? So close the welcome screen, and yeah, this is the project that I just created for the previous section. I'll close it and recreate it from scratch, okay? So close this project. Okay. So what you want to do is to go to File first, and then click on New, okay, New, and then Project, okay, Project. Okay, you need to change the project location and project name. Okay, make sure that the project location is in a place where you can find it easily, like for example my documents. Okay, so I have it here under my documents, term 231 COE 202, and then that's the selected folder. But for now, I'm going to change this folder to a subfolder, let's say, for section 5. Okay, this is for you guys. Okay, double click on that to select this folder. Okay, and then I will select this folder. Okay, and give this project a name. So let's call it project 1. Okay, project 1. Click OK. Don't change anything else. All right, then you need to create here a number of files equals to the number of modules that you need to implement. So let's create one module. Okay, click on create new file, and then here in this dialog box, write down the file name mod1. Okay, and it will give it the correct extension just by choosing the file type. It's not VHDL. We want Verilog. Okay, Verilog, and it's not system Verilog. It's Verilog. Okay, make sure that you change this to Verilog. Click OK, and the file will be created. Okay, we'll also create another file, but for now, let's fill in mod1 content. Okay, double click on it here. Yeah, maybe I need to close this, but okay, close this. Right. So double click on this to basically edit it using your default editor, and it happens to be Notepad in my case. So I'm going to create an arbitrary module here. Okay, I'm going to say module mod1. Okay, and I'm giving it going to give it some input ports A and B. Okay, and output ports. Let's say, for example, W and Y. Okay, and of course, module, end module, and your content is in between. Okay, so let us say that we would like W to be the output of an AND gate. Okay, output of an AND gate of A, comma B. Okay, let's make it more interesting. Let's keep it simple. You know what? Let's keep it simple. And the output of Y, or the Y output is the output of, let's say, a NOR gate. Okay, of W. This is Y. The output is Y, and I'm NORing W with A, for example. Okay, all right, so let us try to analyze this. Okay, I can use comment lines here. Okay, this is a comment, how you write a comment. This is how you write a comment in Verilog. Okay, so my W is in Boolean algebra, it's AB. Okay, and my Y is what? W or A. The whole thing is NOR together. Right. This equals, substitute W. No, W is what? AB, right? Or with A, and the whole thing is NOR. يا شباب يلا اللي راجعوا ذاكروا الكويز. What does this equal to? A complement, isn't it? By absorption. صح?
Yes.
So we expect Y to be a complement, basically. Okay? Right. This is mod 1. Now I'm going to create another module here. So since I closed the creation tool for the modules, I can right click and then say add to project and then new file. Okay, mod 2. I'm going to call it mod 2 and make sure that it is in Verilog. Okay. Right. Double click it. Okay, and I'm going to write module mod 2. So the name of the module and the name of the file must match. Okay, I'm going to call the inputs let's call them, for example, x1, x2, and the output I have, for example, let's say O1 and O2. Yeah. No, let's choose a different name. Let's choose, for example, R1 and R2. Okay. And then end module. Now I'm going to show you how to utilize or how to use or reuse your mod1 in another module. Okay, so I'm going to instantiate it here. Instantiate mod1 inside of mod2. Okay, but I need to, so how do I do that? First of all, I need to give the name of mod1, which is mod1 in this case, and then give it an instance name. Okay, instance name of your choice. Okay, let's call it M1, and then you need to, oh man, just close these. Okay. You need to hook up the inputs and outputs of mod 1 and mod 2. Okay, so for this, I'm going to just create a hypothetical example in which mod 2 is just a black box view of mod 1. Okay, so my x1 of mod 2 is connected to A of mod 1, input name A of mod 1. Okay, and my x2 of mod 2 is connected to input B of mod 1. And my output, which is R1 dot R1, notice the dot, by the way. Okay, dot before the name of the port. Hold on. I think yeah, I got it. No, actually, it's the other way around. So I need to say, well, my A of mod 1, okay, is connected to x1 of mod 2, okay, and my B of mod 1 is connected to x2 of mod 2, okay, and my W, it doesn't have to be in the order. If you are binding the ports by names, it can be in any order, by the way. Okay, my W of mod 1 is connected to R1 of mod 2, and finally my Y of mod 1 is connected to R2 of mod 2. Okay, so this is all what it does. It doesn't do anything useful except that it is abstracting mod 2. Okay, I just wanted to show you how you can instantiate modules inside other modules. Okay, save that. Okay, and make sure that you save also mod 1. Okay, you have to save both. Okay, in order to see the effect. Now we will create a test bench in which we will instantiate mod 2 and simulate it. Okay, so right click, add to project, new file, and say test bench tb, and make sure it's Verilog. Okay, okay, and then double click tb.v, double click it to open it up in Notepad or whatever your default text viewer. Module tb, it doesn't have any parameter, just a semicolon here, and end module. Okay, so now I need to instantiate a module that I'm going to simulate, which is, in this case, happens to be mod 2. And I'm going to give it a name M2. Okay, this name can be anything of your choice. And then open up the bracket, and then let me open up the interface, the port declaration for mod 2. So notice here that I have mod 2 have x1 dot x1. Come on, what happened? Okay, dot x1 of mod 2, okay, is connected to something in the test bench, and dot x2 in mod 2 is connected to something else, and dot R1, I'm copying the names from here, by the way. Okay, R1 is connected to something else, and dot R2 is connected to something else. Okay, that's it. But we need to find out what are these something else's. Okay, so in a test bench, you would like to what we call drive the inputs and observe the outputs. Okay, so to drive the inputs, they must be variables. Okay, they must be registers in order to be able to change their values. Otherwise, if they are just nets, their outputs, for example, you can only observe them. Okay, so in order to create a changeable net or a variable net type, you use the register keyword. Okay, register, and you say, well, I have a register called I1 and I2. Okay, so here I know that my X1 will be connected to I1 and my X2 will be connected to I2. Okay, and I also would like to observe the output, so I'll create wires O1 and O2. Okay, and these O1 and O2 are connected to R1 and R2. Okay, now the connections are done. Okay, we are done with respect to the connections. What we need to do now is to create the simulation logic. Okay, we'd like to say apply this pattern, then wait for a specified number of time units, and then apply another pattern, and so on and so forth. This can be done using the initial block. So we say initial, and then we say begin, and then end, and in between that we apply our pattern. Let's say for the sake of illustration, I'm going to apply 0, 1, and then 0, 0, and then 1, 0. Okay, 1, 0. All right, for the sake of just illustration, that's just 3 patterns. Okay, and then observe the outputs for these 3 patterns. So I1 at the beginning, I1. By the way, Verilog is case sensitive, so make sure that you follow this case sensitivity thing in Verilog. So I1, little I1 is different from little capital I1. Okay, so little I1 equals at the beginning 0, and then little I2 is equal to 1. Okay, then I'll wait for 10 time units. Okay, and then apply the next pattern. Do I need to change I1? Do I need to change I1 for the second pattern here? You see, I1 was 0, and I want to change it to 0. Do I need this change? Answer is no. Yeah, excellent. You don't need to change it. Okay, just keep it as is. Don't change it. If you even if you put I1 equals 0, this will be ignored by the system because it's the same value as before. Okay, so why put it? So you can say, well, I'm just changing I2 because I2 goes from 1 to 0. Okay, then after 10 time units, okay, pound 10. Okay, you change what? No, you change what? You change I1 because I1 is the one that changes to 1. Okay, and then I'm going to wait to apply this last change for 10 time units, 10 more time units, and then execute a stop command. Okay, to stop the simulation. Okay, so save this. Make sure that you saved everything. Okay, save mod 2 and save mod 1. Just make sure that you saved everything, and then here in ModelSim, go to compile. Sorry, my computer is not responsive. A little bit not responsive. Come on. It just closed ModelSim for some reason. Let me just open it because, alhamdulillah, we have saved our work. Hopefully, it will not be lost.
Okay. The default project will be the project that you opened last time. You see if that's the one that we are in. Okay, yeah, section 5. You see section 5, project 1. Okay, great. So I have finished writing my modules. What I need to do is to compile all. Okay, compile all. If you have a bug, it will be shown in the transcript below. Okay, here, but there is no error, alhamdulillah, and everything went smoothly. You can see the check marks here. Okay, if there is something wrong, you'll see a sign for mistake. Okay. So now after compilation, you can start the simulation. Successful compilation, you can start the simulation. And to start the simulation, you are in the project tab, click on the library tab. Okay, and then the default library is work. Okay, so expand it and then click on, this is the module that we'd like to simulate. It's TB, the test bench. Double click on it. It will open up the simulation environment for you. Okay, with a placeholder for the waveform. Okay, and you can see that these are the signals that you can observe in the test bench. Okay, these are the signals that you can observe for the test bench. Currently, none of them is added to the waveform. You can add them to the waveform by selecting all of them, just Control A, okay, and then Control W, or right click and add to wave. Control W to add them to the wave. Notice that they will be added here. Okay, right now everything is ready for the simulation. We can go ahead and click on simulate button and then start simulation. Okay, start simulation. Actually, it's already started. This is exactly what we did, was create a simulate. This will start simulation, will create this for you. Okay, now we need to run the simulation. Okay, run all. Okay, and make sure that you have a stop statement, otherwise the simulation will run forever if you select run all. Okay, so run all, and then it will break at the stop statement. You see, it broke at the stop statement here. Okay, to go back to the waveform, you click on the wave, and then just make zoom full, okay, to see the wave in full scale. And you can see here that every 10 time units, we change the value of I1 and I0. Okay, so we start with 0, 1, and then 0, 0, and then 1, 0. You see that? What was the expected value of all? Let's see. Of all of W, which is O1. It is the ANDing of the two inputs. Okay, so 0 ANDed with 1 is 0. 0 ANDed with 0 is 0, and 1 ANDed with 0 is 0. Actually, this is O1. Okay, and for the other input, it was what? A complement, right? Which is the complement of input 1. Okay, so this is input 1. It goes 0 until here, and then 1 here. So this is the invert of input 1. You see? Okay, everything makes sense. Okay, so I'm going to show you another way to implement the circuit using behavioral assigned state. So instead of saying here, this is called, this format here is called gate level netlist or description. Okay, gate level netlist. Okay, now I can create, so if I would like to create an assigned statement form of this circuit, I will comment out these two gates, and then create an assign statement instead. Assign, and then I start with the output variable, KW, to be A ANDed with B, okay, semicolon. This is exactly the same effect as giving this AND gate. okay? But this is a behavioral, more than a behavioral way of looking at the problem, okay? Also for y, I can say assign y equals, how do I create the or? Okay, first of all, I need to say w, the pipe and a. Okay, pipe is or here, but it is an or, so I need a complement here. The complement is the tilde character. Okay, so this is exactly the same file, equivalent file of mod 1, but using a sign statement. I'm going to save it and take a mental image of the current simulation output. All output number 1 is always 0, and then output number 2 is 1 until 20 picoseconds, and then it becomes a 0. Okay, I'm going to save this now. Okay, and then go to project. You need to, since you saved, okay, since you changed one of the files, you need to recompile. Okay, you need to recompile, compile all. Okay, until you get the check mark here. Okay, and then go back to simulation tab. Okay, and then in the simulation restart. You have to restart and then run again. Okay, run all. Isn't it the same? Isn't it the same?
Yes,
it is the same. Yeah, same function. طيب. Another thing that we want to cover today is to model, how to model delay. Okay, delay in logic gates, and assign statements as well. So let's start with the assign statement since we are at it now. So to add a delay at the level of assign statement, you just write the delay here, pound, and then 1. Okay, the computation of the output here takes 1 time unit. This is what it means. Okay, and for this, you can say, well, it's again 1 time unit because it's just the NOR gate. It's exactly the same delay as the AND gate. Okay, almost, let's say. So this is introducing delay. Okay, in the module. Okay, and save it, and then go back here and project, and you have to recompile it. Okay, compile all, and then go to simulate again and restart. Okay, and then rerun. You see here, at the first 1 time unit, we don't know what is O1 because there is a delay of 1 time unit. Before 1 time unit, we don't know what was the input, so we don't know what is the output. After 1 time unit, the output O1 will take the value of ANDing for basically 0 with a 1, which is a 0. Okay, same thing happens here. When will this change take effect? It will take effect exactly at here, but here it's not really shown because basically the O1 is always 0. Okay, but it should be delayed by 1 time unit. For example, let's take a look at O2. You see here, O2 is equal to a complement. Okay, so when does the change happen? After 1 time unit. Exactly 1 time unit happens. Okay, you get that? All right. So let's see how we can introduce a delay in the gate level format. Okay, I'm going to reactivate the gate level now and show you how we can introduce the delay at the gate level. So between the and its bracket, you insert the delay. Okay, so this is like I have an AND gate whose propagation delay is 1 time unit. Okay, and I have another gate, NOR gate, whose propagation delay is 1 time unit. This is exactly the same as this implementation. Okay, so save it and go back to the project Okay, and project, and recompile, and then go back to simulate, restart, and rerun. Okay, it's exactly the same output as expected. All right. So with this, we actually finished the material for Verilog part 1. Okay, but let me let us try, for example, to make things more interesting for module 2. For example, module 2, let's change it, for example, to let's change it to creating 2 instances of module 1, since so I need to give this instance a different name. Okay, fine. But here is what I will do. I will connect A and B of mod 1, okay, M1 to X1 and X1, and mod 2 to X2 and X2. Okay, but I need 4 output because I cannot drive the same output using 2 signals, okay, using 2 drivers. So I need 4 outputs here: R1, R3, R2, R3, R4. Okay, so I need to say here R3 and R4. Okay, so in this way I have created 2 instances of module 1 and module 2. And I need to change what else do I need to change? I need to change the test bench, but let us try to compile and see the error that we get. Okay, for not changing the test bench. Actually, okay, we didn't get an error because we're using positional very positional port declaration here. Okay, meaning that R3 and R4 are not connected. Okay, but we need to actually connect them. So dot R2 or R3 is connected to, I'm going to create the signal O3, and finally dot R4 is going to be connected to O4. Okay, so I need to create 2 different wires here, O3 and O4. Okay,
Sir, we need the comma between R3 and R4, right?
yes, thank you for that. I wish that he didn't say it so that we make a mistake and then come back and debug, but that's fine. So now I believe everything should work as expected. Okay, and then again you say, well, restart. Okay, but I need to include also O3 and O4. Okay, O3 and O4, and for this, Control W. Okay. So let me scroll down a little bit here so to see all the waves. Okay, all right. Right. So go to simulate and then restart, and then run all. Okay, run all, and then go to wave. Okay, let's see whether this is what we expect or not. Okay, first of all, let me remove the delay so that it doesn't. Let me remove the delay so that it doesn't. It makes things easier to imagine. Okay, compile again, and restart. simulate, run all. Okay, now do we have O1 and O2 as expected? يعني O1 is what يا شباب? It was ending of the inputs, صح? It was the ending of the inputs, and my inputs is I1 and I1, right? In this case, is it I1 and I1? Let me see the test bench. Test bench is, yeah, I1. And then if I go to module 2, okay, I'll have one module 1 connected to, I'm just ending here. R1 is going to, or W is going to be what? Ending of X1 and X1, okay? Which is basically X1, okay? So, yeah, you can see here that O1 is following I1. You see that? It's following I1. And then O2 is following I2, isn't it? No, actually, O2 is the complement. So O2 is actually, where is mod 1? Mod 1, yeah. We said that the second output is the complement of the first input. So it is basically the complement of I1. This is exactly, so this output is the complement of this output. And this output is the complement of this output. So this is exactly what we expect, okay? Yeah, this is just to show you a little bit more information. I'm going to stop recording so that the video doesn't become very long, okay?